Hello, Doc Pao. Hello, classmates. Good evening. I am Sharon Joyce Valdez. You can call me SJ, and I am reporter number 5. And before I proceed with my report, let me show you some slides. Okay. Do you know that a person has an average of 1,460 dreams in a year? And the average time for a person to find a new job is 5.9 months. And a person looks on average at about 14 homes before he or she buys one. And the safest day of the week for driving is Tuesday. Male dogs bite children more than female dogs do. However, female cats bite children more often than male cats do. And, and the average number of faces that a person learns to recognize and remember during his lifetime is 10,000. Isn't it amazing that we see these facts? And as we all know, these facts are made possible because of statistics. Statistics is everywhere. You can experience it when you read on surveys, when you go to the supermarket, and when you see, for example, if you're a content creator and if you look at the insights of your Facebook page or Instagram, and if you learn about your viewers, if more of or if the majority of them are female or male, statistics ang may kagagawan niyan. So we should not be afraid when we hear or encounter the word statistics. With all honesty, last sem, I was afraid to enroll in Dr. Ed's class kasi when I hear the word statistics, parang iniisip ko, nako, mathematics to, nako, puro numbers to, ayoko talaga ng math, ayoko ng numbers. But when I was able to get the hang of it, I was able to enjoy it. Eh, ang galing-galing naman kasi ni Doc Ed, di ba? Kaya na-enjoy ko yung statistics. Then I realized that statistics is more than mathematics. Statistics is science, and it is also a language. And then in line with that, my report for today is basic statistics for psychological tests. Okay, here in my report, we will not focus on how to compute different statistical concepts, or we will not focus on the formulas, but we will focus on the different terms and concepts that are used in psychological tests. So, when Dr. Paho gave me this topic, medyo kinabahan ako. Kasi sa totoo lang, my background in statistics is not that strong. That's why when I got this topic, sabi ko, nako, kailangan ko ulit mag-aral. Kailangan ko ulit i-refresh ang sarili ko. And that's what I did. For 2 weeks, I did my best to look for the common statistical terms that I should share with you. And as much as possible, I did my best to make it easier for me and for you to understand. So I hope that today you will learn something from me. Yung kahit paano may maibaon man lang kayo na matandaan dito sa ating report. Here in my report, you will see easy definitions of the different statistical terms. And I also have here some videos in order for us to understand how they are used. So let's start. Okay. The key ideas that I'm going to show to show you here, or we will the key ideas that we will discuss here are the following. First, we have to define statistics, and we have to know its importance in psychology. We also have to review some common statistical terms that we will come across as we study psychometrics. And we have to identify the statistical tools needed to show test results. And we have to know the uses of different statistical tools, their use in psychological tests, and why they are important. So, what is statistics? Okay. Statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. And statistics uh, was introduced by a Scottish landowner and president of the Board of Agriculture, Sir John Sinclair. He introduced it into the English language in 1798 uh, through the publication of his book on the statistical account of Scotland. And the word statistics is derived from the Latin word status, which is loosely defined as statesman. Then, why do we study statistics? We study statistics because as professional people, we must be able to read and understand the various statistical studies performed in our fields. So, to have this understanding, we must be knowledgeable about the vocabulary, symbols, concepts, and statistical procedures used in these studies. And of course, in our field, we may be asked to conduct research and statistical procedures, as we all know, are basic research. And to accomplish this, we must be able to design experiments, collect, organize, analyze, and summarize data, and possibly make reliable predictions or forecasts for future use. And of course, after doing the research or experiment, we have to communicate the results of the study in our own words based on statistical or based on facts that was uh, the result of statistics. And also, we have to use the knowledge gained from studying statistics to become better consumers and citizens. Siyempre, for example, we should make intelligent decisions about what products to purchase based on consumer studies. And of course, we also learn how uh, to what do you call this, to take a closer look on government spending. Siyempre, dapat maintindihan natin kung saan napupunta din yung mga perang inuutang or yung mga kinikita ng mga taxpayers, dapat marunong tayong mag-analyze dyan. And it is based on the utilization of studies and so on. And why is statistics important in psychology? Of course, psychologists rely heavily on statistics to help assess the meaning of the measures they make. And sometimes the measurements involve individuals who complete psychological tests. And other times, the measurements involve statistics that describe general properties of groups of people or animals, for example. And in psychological testing, the psychologist may interpret test results in light of norms or the typical results provided from previous testing. So, what are the two major areas of statistics? First, we have the descriptive statistics. What is descriptive statistics? Okay, it includes data collection, organization, summarization, and presentation. And the statistician tries to describe the situation. Kaya nga descriptive statistics. Describe, description. Yun ang ibig sabihin yan. And for us to understand descriptive statistics, I'll give you some examples. Okay, we use descriptive statistics to compute percentage, measures of central tendency, mean, median, and mode, and measures of dispersion like range, standard deviation, variance, and correlation coefficients. We will discuss this further. Medyo baka mag-nose bleeding tayo. So we will discuss this further later, no? So, paano na-discover ang descriptive statistics? Okay, share ko lang sa inyo. The origin of descriptive statistics can be traced to data collection methods used in censuses taken by the Babylonians and Egyptians between 4,500 and 3,000 BC. And in addition, the Roman Emperor Augustus, he's the first Roman emperor, conducted surveys of births and deaths of citizens of the empire, as well as the number of livestock each owned and the crops each citizen harvested yearly. Kasi di ba nagbibigay sila ng tax. Well accounted yan ni Roman Emperor Augustus. Mahigpit siya. Okay? And next, aside from descriptive statistics, we have inferential statistics. This is the subject that Dr. Ed De La Cruz taught us last sem. Okay? Inferential statistics includes making inferences. What do you mean by inferences? It is a conclusion reached on the basis of evidence and reasoning. And these inferences come from, example, samples to populations, estimations and hypothesis testing, and determining relationships, and making predictions. So, yon. So natin, yan ang inferential statistics. Magkaiba sila ni descriptive statistics. And saan nag-originate ang inferential statistics? Inferential statistics originated in 1600s when John Grant published his book on population growth. And the book is called Natural and Political Observations Made Upon the Bills of Mortality. Diyan unang ginamit ang inferential statistics. And about the same time, another mathematician and astronomer, Edmund Halley, published the first complete mortality tables. Dito nagsimula yung ginagamit na table ng insurance companies to determine life insurance rates. Yan. Ang nag-imbento niyan si Edmund Halley. And what are the basic concepts of statistics in psychology? Okay? Dito, papasok na ang different statistical terms. Okay? First, we have the data. What do we mean by data? Data are the values or measurements of observation that the variables can assume. Okay? And ano naman yung variables? Variables are any measurable conditions, events, or behaviors that are controlled or observed in the study. Sige, para maintindihan natin yan, let's move forward. Okay, we have different classifications of variables. And the first one is, qualitative variables. Ano ba ang qualitative variables? Okay, qualitative variables can be placed into distinct categories according to some characteristics or attributes. Yan. Example ng qualitative variables, gender, male or female, religious preference, and geographic locations. Okay, next. Quantitative variables. Anong pinagkaiba niya? Ang quantitative variables can be ordered by rank. Yan ang pinagkaiba niya sa qualitative variables. And an example of this is are the following. Age can be ordered by rank, right? And height and weight. You can rank them too. And of course, body temperature. Yan. Okay? There are different types of qualitative variables. Okay? And the first one is discrete variables. Diba, sinabi nga natin, yung qualitative variables can be placed into distinct categories and can be described according to characteristics and attributes. And tatandaan natin yung characteristics and attributes and placed into distinct categories. So the first example is discrete variables. Discrete variables, these are variables that can be assigned such as 0, 1, 2, 3, and tatandaan natin na discrete variables, countable sila. Okay? And the type of qualitative variables, discrete variables, example niya ay number of children in the family. Of course, we can count the number of children in the family. Number of students in the classroom. Ayun yung klase natin. Are we 18 or 17 or 18? So, ayan. Discrete variables tayo, na? And amount of money in your bank account. Yan. You can count your money in the bank, so it's discrete. It's a discrete variable. And a person's age in years. Ayan. And a baby's age in months. And of course, the number of calls by a switchboard of the number of calls received by the operator each day of the month. You can count them all, right? So they are discrete variables. And next is continuous variables. Ang pinagkaiba ng continuous variable sa discrete variable ay, okay, they are obtained by measuring. Oh, so, hindi mo sila mabibilang kung hindi mo sila mine-measure. So, that's the difference. And oftentimes, they include fractions and decimals. Example of continuous variables are, yan, una, temperature, di ba? Since this variable can assume an infinite number of values between two given temperatures. Mame-measure mo yan. Hindi mo siya pwedeng bilangin kung hindi mo siya i-measure. Ano pa ba? Example ng continuous variables. When you measure the length of a wooden stick, yan. Continuous variable yung kanyang measurement. Okay? And other types of variables aside from qualitative and quantitative variables are, okay, first, we have the independent variable. What is an independent variable? Ito yung sa research, ito yung data that is manipulated. Okay? It is being changed or controlled by the experimenter. Kaya nga siya namamanipulate. And it is assumed to have a direct effect on the dependent variable. O mamaya i-explain natin yan. Okay, independent variable, tandaan, it has an effect on the dependent variable. Okay. The two examples of common independent variables are gender and educational level. Okay, you can manipulate it eh. And you can, educational level can be manipulated then. And what's next? We have the dependent variable. Yan. Ito yung measured variable. And of course, it is being measured in an experiment and is dependent on the independent variable. Okay, ang dependent variable mo ay maaapektuhan ng independent variable. Mamaya natin i-explain yan. Okay, an example is depression symptoms, which depends on the independent variable. And what is that? Type of therapy. Diba? The type of therapy can affect your depression symptoms. So, diba? The dependent variable depends on the independent variable. Okay, next. We have the intervening variable. What is intervening variable? Isipin nyo na lang, siya yung nasa gitna ng dependent and independent variable. Okay? Yan. It is mediating or intermediary variable and it intervenes between the dependent and independent variable. Yan. Example tayo ha. I'll show you. Ayan, nakita nyo, here, the independent variable is poverty, and it's intervened by the intervening variable, which is the lack of access to healthcare. And the dependent variable is shorter longevity. Paano ba to? Ano bang ibig sabihin nito? Itong poverty or the independent variable can be manipulated, right? And the intervening variable mediates between the independent and independent variable. And the dependent variable is measured. So for example, in the longevity, for example, no, yan, the independent variable, for example, is money or lack of, okay, lack of money. So, nagkakaroon siya ng poverty, di ba? And the dependent variable is longevity. So, the lack of access to healthcare, for example, or poor nutrition intervene or fill the gap between the independent and dependent variable. So, yun yung explanation doon, di ba? I hope that you're able to understand the relationships among these three based on our example. Okay, next. Okay, another trivia. Saan ang galing ang intervening na word na yan? Ayan, the term intervening was first used for variables by behavioral psychologist Edward C. Tolman in 1938 during studies on rat behavior for food rewards. Okay? Doon sa study niya, sabi niya, he suggested that hunger was an intervening variable, okay, which was observed during the actual experiments. And Tolman's work on intervening variables was an extremely important contribution to cognitive psychology, as the concept made it possible to consider and measure unseen behavior. So, when you study behavioral modification, you will encounter Edward C. Tolman. Okay, next. We have, what is measurement? Okay. When we hear the word measurement, isipin natin, we are measuring the length of something. Okay? For example, the length of a piece of food, or measuring a quantity or something like, for example, a cup of flour. Okay? And measurement in statistics, okay, is the term used more broadly and is more appropriately termed as scales of measurement. So sa statistics daw, ang tawag sa measurement ay scales of measurement. So ano ba yung scales of measurement na yan? Okay? The scales of measurement refers to the ways in which variables or numbers are defined and categorized. Yan. Mamaya i-explain ko sa kanyo kung paano to. Okay? Yan. Sabi, yung scales of measurement daw, you assign numbers or symbols to characteristics of things. For example, yung tao, may i-assign kang number sa kanila, yung events, okay, or whatever, dun sa, limbawa, dun sa test mo or dun sa research mo. And those assigning of numbers are according to the rules, okay? And the rules used in assigning numbers and guidelines for representing magnitude or some characteristics of the object being measured. Example, ayan, mag-a-assign ako ng number 12. Ayan, lahat ng number 12, i-assign ko yan halimbawa sa lahat ng lengths ng mga bagay-bagay na may length na 12 inches. So, para hindi malito, lahat ng measurements, okay, the same as the length of a 12-inch ruler. Bawa, wood, a wooden stick, or yung folder, halimbawa, yan yung halimbawa yung variables natin, i-assign ko yung measurement nila. If they measure 12 inches, so lahat sila inanumberan ko ng 12. So, ganyan yung ginagamit na, yun ang scales of measurement sa statistics. And there are four scales of measurement. Ang four scales of measurement natin ay ang mga sumusunod. Okay, first, we have the nominal level of measurement. What is nominal level of measurement? It classifies data into mutually exclusive, non-overlapping categories. Ito tatandaan natin, no meaningful order or ranking. Ang nominal level of measurement, no meaningful order or ranking. Yan ang tatandaan natin. And an example of this, yung walang ranking ay, of course, ayan, sample of college instructors. When they are classified according to subject taught, hindi mo naman alam kung ano yung performance nila, grade nila, 'di ba? From their principal or from the dean. So, when these college instructors are classified according to subject taught, wala siyang ranking, 'di ba? So, malalaman mo lang teacher siya ng English or he is a teacher of mathematics, psychology, etc. Next, when we classify survey subjects as male or female, walang ranking, right? And classifying residents according to zip codes. Okay? So, yan yung example ng nominal level of measurement. More examples, political party. Yan, democratic ba siya? Republican, independent? Or the religion. Is he a Christian? Does he practice Judaism or Islam? Of course, marital status. Is the person single, married, widowed, divorced, or separated? So those are examples of nominal level of measurement. And another type is ordinal level of measurement. When you see the word ordinal, ano yung iniisip nyo? So, dun pa lang sa pangalan, may clue na. So, ordinal level of measurements classifies data into categories that can be ordered or ranked. Nominal, no ranking. Ordinal with ranking. Comes from the word ordinal, right? So, these are some examples of ordinal level of measurement. We have here, ayan, if you rank the students according to performance, you can rank them as superior, average, or poor. And floats in the homecoming parade, di ba? Yung mga pabonggahan ng mga floats dyan. Kapag halimbawa may mga pakonte sa barangay sa piyesta, sino ba yung first place, second place, etc., etc. So, you rank them according to kung sino ang pinakabongga. Okay? And of course, we have grades. We rank grades. Is it A, B, C, D, E, or F if you're not using numerical grades or numerical grading system? So, pwede rin sa grades natin, dito sa Arellano University, ano ba yung grades? 1, 2, 3, o ganon. And of course, we have the rating scale like poor, good, or excellent. Okay? These are examples of ordinal levels of measurement. Oh, meron pa pala. Ayan. When we rank the performance of tennis players, for instance, or basketball players. And of course, the Likert type scales. For example, yung pain scale sa hospital. From a scale of 1 to 10, how do you measure the pain that you're feeling right now? Like that. So in, in clinical settings too, in line with that, people on a waiting list also can be ranked according to their need of treatment. Lalo na if you are in the emergency room, chine-check, meron yung ranking inuuna ng mga nurses or ng mga doctors yung malalang malala na. So, example pala siya ng ordinal level of measurement. Okay? Next, we have the internal level. Actually, it's interval. I'm sorry. It's interval level of measurement. And interval level of measurement ranks data and precise differences between units of measure do exist. Ano ba yan? Okay? Ibig sabihin, there is no meaningful zero. Okay? So, ano ba tong ranks data and precise differences between units of measures do exist na tinatawag natin sa interval level of measurement? Ang difference ng interval level of measurement from the ordinal level is that the precise differences do exist between units. Explain ko to para hindi tayo malito. So, interval level of measurement. For example, ayan, di ba? IQ tests do not measure people who have no intelligence. So, imposible siya na magkaroon ng zero. Parang ganon, okay? I mean, parang there is no true zero. For example, for temperature, if nakita mo sa thermometer na 0 degree Fahrenheit, it doesn't mean that there's no heat at all. Parang ganon. Okay? So there. So, an example of interval, some examples of interval levels of measurement are the following. Yun nga, we have the temperature, yung mga IQ test standardized test. IQ test are as an example of standardized tests. Lahat ng standardized tests, they are considered under the internal level of measurement, SAT scores, and also the measurement of sea level. There is no, what do you call this? There is no meaningful zero. Parang walang ibig sabihin yung zero. Okay, dito sa interval level of measurement. And one more type of the 4 scales of measurement is ratio level of measurement. Sa ratio level of measurement naman, it is similar to interval level of measurement in that it also represents quantity and has equality of units. Dito, there is an absolute zero. Ano ba ibig sabihin ng absolute zero na yan? Hindi pwedeng magkaroon ng numbers below zero. There is no such thing as a negative. Okay? Let us see some examples so that you can understand this. Okay? Some examples of the ratio level of measurement are, ayan, physical measures, height and weight, area measurement, number of phone calls received. Wala namang, I received -1 phone calls today. My height is -1. Wala namang ganun, di ba? My weight is -50. Okay, so there is no absolute zero. That's what we mean by ratio level of measurement. Okay, I hope you're able to get it. Okay, more examples. Time. Wala namang oras na I woke up at -2 p.m. Diba? Or sa salary, amount ng money, okay, minsan kasi sinasabi natin, ay, nag-negative na naman ako today, pero hindi yun ibig sabihin na yung value ng money, walang negative na value ng money, right? zero, ay wala akong pera, gano'n, or nag-negative ako ngayon, gano'n. Pero ang salary 'di ba wala namang negative na this cost negative 1 peso. Wala namang gano'n, right? And then age. Okay, we are measured from 0 to so on and so forth age. Walang negative. So those are examples of ratio level of measurement. Okay. Here, interval and ratio levels are sometimes referred as parametric. Ano ba ibig sabihin ng parametric? When we say parametric, it means that it meets certain requirements with respect to parameters of the population. For example, the data will be normal, the distribution parallel to normal or bell curve, yung mga ganyan, mamaya i-explain natin yan. So, ito, yung parametric data, these data are being analyzed using statistical techniques identified as parametric statistics. So, sabi, as a rule daw, there are more statistical technique options for the analysis of parametric data. And parametric statistics are considered more powerful than non-parametric statistics. Okay. Pag daw sinabing nominal and ordinal levels, non-parametric daw yan. Ano ba yung non-parametric data? Okay? Non-parametric data, meron daw silang kulang na parameters and they cannot be added, subtracted, multiplied, or divided. So, isip tayo ng example dito. Okay, sa non-parametric data, ang example dito, di ba parang it doesn't make sense to add the social security numbers to get a third person. Parang, sabi na yung non-parametric data cannot be added. Kumbaga, hindi mo naman pwedeng i-add yung kung sino yung naging first at saka second place dun sa race, di ba? Para 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 sabihin mo kung sino yung nakakuha ng third place, parang ganon. So, yun yung explanation ng non-parametric. Hindi mo siya pwedeng i-add para makakuha nung susunod na value. And sabi pa, Likert type scales, kagaya the one that I mentioned a while ago, yung Payne scale, represent ordinal data but are often treated as if they are interval. Halimbawa, okay, may isang tao, halimbawa, hindi mo naman pwedeng sabing the average amount of pain that he reports on a Likert scale over the course of the day would be computed when you add his reported pain levels dun sa buong araw na yun, then i-divide mo. Hindi ganon. Kumbaga, sasabihin ng tao sa'yo yung pain niya on the time that you ask him. Hindi mo siya pwedeng pagsama-samahin yung pain niya kaninang umaga, sa pain niya kaninang tanghali, at sa pain niya sa gabi para makuha mo yung tamang value ng kanyang Likert type scale. So, yun yung explanation dyan. Tapos, sabi, sa psychology daw, okay, ratio level measurement is employed in some types of tests and test items, perhaps which involves the assessment of neurological functions. Yan yung gamit niya sa psychology. And paano ba natin i-explain to? So, halimbawa, intelligence. yung aptitude and personality tests, di ba may score yan? Physically speaking, it is ordinal kasi you rank the scores. Kung sino yung first, yung pinakamataas, sino yung susunod na mataas, sino yung pinakamababa, for instance. So, these tests indicate more or less the accuracy, not the amount of intelligence, aptitude, and personality traits of individuals, but rather the rank order positions of the individuals. Okay? Sabi pa nung isang scientist, si Kellinger, na most psychological and educational scales approximate interval quality fairly well. And some of the techniques, sabi nila, such as the computation of the average, can be used if data are assumed to be interval or ratio level in nature, but not if they are ordinal or nominal. So, in other techniques, such as those involving creation of graphs, mamaya di-discuss natin yan, tables, pwedeng ordinal yan. Pwede mo siyang i-rank or pwede mo rin siyang i-measure or what you call the nominal type of data. Okay? Ayan. Sa psychology, ordinal level of measurement is most frequently used. You rank people by intelligence, you use the Likert scale, right? To see if the person performs well, like if his performance is very outstanding, very good, good or average or poor. So, psychology, pinaka-common yung ordinal level of measurement. Ayan. Discuss na natin yan kanina. And may trivia ulit ako sa inyo. Okay, when data was first analyzed statistically, if you're familiar with the surname person, lagi nating nakikita yan sa statistics, sa mga formula, right? The Pearson R. Okay. When data was first analyzed statistically by Carl Pearson and Francis Galton, almost all were continuous data. And in 1899, Pearson began to analyze discrete data. Then Pearson found that some data, such as eye color, could not be measured. Kaya tinerm niya, he used the term such as nominal data because the color of the eye can be measured. And the ordinal data were introduced by a German numerologist, Friedrich Moss, in 1822 when he introduced a hardness scale for minerals. For example, the hardest stone is a diamond, which he assigned a hardness value of 1,500, and quartz was assigned a hardness value of 100. And this does not mean that a diamond is 15 times harder than quartz. Nirank lang siya according to hardness, pero hindi naman ibig sabihin nun na ang diamond is 15 times harder than quartz. Okay? And in 1947, a psychologist named Stanley Smith Stevens made a further division of continuous data into two categories. Siya yung nag-name ng interval and ratio. Okay. Describing and organizing data. What do we mean by distribution and row score? A distribution may be defined as a set of test scores arrayed for recording or study, while the row score may reflect a simple tally, as in, tally lang talaga siya. Their number of items responded correctly on an achievement test, for instance. Distribution, again, a set of test scores, and a row score, it's just simply a tally. Ayan. Ito, this is an example of ano lang to, teka. Oops. Example nito, ayan, no? This is just a tally. And what is frequency distribution? Okay. Frequency distribution is a tabulation of scores ordered either in ascending or descending value. Mamaya i-discuss din natin yan. I'm going to show you some videos, okay? Dito sa frequency distribution, all the scores are listed alongside the number of times each score occurred. And the scores in the frequency distribution might be listed in tabular or graphic form. Tapos, to make the definition easier, frequency distribution is the organization of raw data in table form using classes and frequencies. Why is frequency distribution important? Frequency distribution or the tabulation of scores, and tatandaan natin na frequency distribution is a tabulation of scores. Okay, tabulation of scores para hindi tayo malito. They are used to organize the data in a meaningful and intelligent way, and of course, it enables the reader to determine the nature or shape of the distribution. Later, we will show you how does it mean. Okay, next. Frequency distribution is used to facilitate computational procedures for measures and average spread. And it is used to enable the researcher to draw charts and graphs for the presentation of data. Kasi nga ano siya, tabulation of scores. So, magagamit siya ng mga researcher para mag-draw ng charts and graphs to represent the data. And it enables the reader to make comparisons among different data sets. Okay? These are the types of frequency distribution. Here we have simple frequency distribution, and the other one is the group frequency distribution. Okay, in simple frequency distribution, the data have not yet grouped. While as in group, of course, group nga, summarize na yung data. Okay, simple frequency distribution, data have not been grouped, while in group frequency distribution, summarize na yung data. I'll show you an example. Here. Okay. As you can see, table 3-2, this is an example of a simple frequency distribution. Not yet grouped sila. The scores are not yet grouped, right? And here, sa group frequency distribution, obviously, they are grouped na and they have intervals. Ayan o, meron na siyang tawag dito, nakagrupo na siya. Kumbaga, like for example, when the class interval is 99 to 95, ang frequency of distribution niya, 1, ganon. Meron siyang range. Yun ang difference niya sa simple frequency distribution. And further, these are the different graphical illustration of frequency distribution of test. Of course, sabi ko nga kanina, you can describe frequency distribution or tabulation of scores by means of a graph. And a graph is a diagram or chart composed of lines, points, bars, or other symbols that describe and illustrate data. Ayan. When you use the graph to illustrate the distribution of test scores, they can be understood easily, right? And There are types of kinds of graphs used to illustrate frequency distributions, and they are the following. We have the bar graph, the histogram, and the frequency polygon. Ano-ano ba yan? So, without further ado, I'm going to show you a video so that you can see the difference or the similarities of the first two types of graphs that I mentioned a while ago. And these are the bar graph and the histogram. Okay, let's watch.
Hello, welcome to Moo Math, where we upload a new math video a day. In this video, I'd like to talk about the difference between a histogram and a bar graph. A histogram and a bar graph both are ways to graph data. Both have an X and a Y axis, and both use a bar to display the data. With a histogram, the categories are numerical. For example, notice in this histogram, the x-axis is the age of the people in the room. The ages are grouped in a numerical range. In this next example, the histogram is graphing the score on a test and the number of people who scored in each range. Also, the bars touch with a histogram. A bar graph uses categories such as the types of movies, color of eyes, and the bars do not touch. For example, with this bar graph, the categories are grade level and the number of student in each grade level. Notice that the bars do not touch. In another example, the categories are types of videos and the number of videos in each type. Again, notice the bars don't touch. In summary, histogram have bars that touch and use quantities. Bar graphs have bars that don't touch and use categorical data. Thanks for watching. Moo Math uploads a new math video every day. Please subscribe and share. Hello, welcome.
Okay, so to further explain the difference between the bar graph and the histogram, as a histogram is only used to plot the frequency of score occurrences in a continuous data set that has been divided into classes or what we call bins. While in bar charts, on the other hand, they can be used for other types of variables, including ordinal and nominal data sets. So let's move on to the next slide. Okay, dito naman, you'll see the purpose of the frequency polygon.
In this table, we have the price range in one row and the frequency in another. 15 pens that cost between 10 and 20 rupees were sold. 20 pens that cost between 20 and 30 rupees were sold, and so on. Frequency is simply the number of times something has occurred, or you can say how frequently something has occurred. And these intervals, as we can see, are continuous. The upper limit of one is the same as the lower limit of its next interval. We saw how we can draw a histogram for continuous class intervals. We have the x and the y-axis. We have the class intervals on the x-axis and the frequency on the y-axis. For the interval 10 to 20, we draw a bar to represent 15 pens. For 20 to 30, we draw a bar to represent 20 pens. Observe that here there are no gaps between the bars like we had in the bar graph. In the same way, we draw bars for the remaining 3 intervals. We use histograms to represent class intervals. While drawing a histogram, we have the class intervals on the x-axis, while for a bar graph, we have categories. But here's something really interesting. Sometimes we may not need to draw the entire histogram. Instead of drawing bars for the histogram, we draw something like this. Let's remove the bars and see how it looks. This just about tells you what the frequency is for a particular class interval. This is called the frequency polygon. Frequency as it represents the frequency of each class interval, and polygon as it has many sides. There are two ways to draw this, and we have made two separate videos for each. Make sure you watch them.
Okay, so we don't need to watch them kasi importante lang naman malaman natin kung paano siya ginagawa. So, okay. I just want to add, for frequency polygon, they serve as the same purpose as the histogram, but they are specifically helpful in comparing multiple sets of data. So may nabasa pa nga ako, sabi, mas maganda daw when we use the frequency polygon, it should be combined with the histogram para mas malinaw siya. And let's move on to the next slide. Okay. We're still in frequency distribution. So we'll go to measures of central tendency. The measure of central tendency is a statistical measure to determine a single score that defines the center of the distribution. And the goal of measures of central tendency is to find a single score that is most typical or most representative of the entire group. And here are the measures of central tendency. We have the mean, median, and mode. Okay. The mean is what we call, para madali nating matandaan, the average. Okay? Median is the boundary, while the mode is the highest frequency. Okay, to explain further, let us watch this video.
Mom, I'm stuck on this assignment. It's on mean, median, and mode.
Oh, Cody. We'll take a break for a second and take the trash out, and then we'll get to work on it.
Okay.
Psst, down here. Hear you're in a little trouble with your mathematics.
Yeah, your math.
Who are you?
We are the Triple M crew from Guttertown.
Yeah, Triple M.
And if we help you, you can help us.
Yeah, we'll help you.
Got me?
Okay, what do you got?
I'm the mean toad. To get mean, like me, take a set of numbers or data and add them up. Then you count how many numbers you got. After that, you divide the sum of the numbers by how many there are. That is the mean, or sometimes called average. So basically, you add and divide.
You add and divide. You add and divide. The way that you get the mean is you add and divide.
Add and divide. Oh, yeah.
Median. I'm the median toad, the one in the middle. You see me? Median, in the middle.
Get on with it, median.
Okay. To find out what the median is, you first make your data list in order, from least to greatest. Then, you find what number falls in the middle.
Tell them what happens if there's an even amount of numbers.
There's an even amount of numbers. Circle the two numbers in the middle. Then add those two numbers together and divide them by 2. In the middle for median. Circle the number in the middle. Add and divide by 2.
In the middle. Oh, yeah. Last but not least, it's me, the mode toad. What I do is I find the most common number, the most popular, like me, of course. First, I make up my list from least to greatest. Then, I see if there are any numbers that are the same. The most numbers that are the same are the mode, like me, the most popular.
Put all the numbers in a line. Small to big, you're doing fine. Match the numbers that are the same. When you do it, mode's the name. Only the numbers that are alike. Let the others take a hike.
Mode is popular.
Thanks, Toads. Now what can I do for you?
Just stay green, Cody boy. Stay green.
Yeah, stay green.
Okay, Cody. Ready for me to help you with your homework?
Mom, just relax. I got this.
Oh, yeah.
Okay, that is how we can easily explain mean, median, and mode. Okay. Before we go to this topic, I would like to share with you which is the best measures of then what do you call this? What is the best to use among those three? Okay. When you have symmetrical distribution for a continuous data, the mean, the median, and the mode are equal kasi symmetrical siya. But in that case, most of the analysts use the mean because it includes all the data in the calculations. So pag symmetrical ang distribution, mean is the most used among those three. And when you have ordinal data or when you rank the variables or arrange the variables according to rank, the mean, the average, or the mode, or the data with the highest frequency are usually the best choice. And when you have categorical data naman or for variables arranged in categories, the mode or the most popular value or the value with the highest frequency is used. Okay, so let us move on. Measures of spread and variability. Variability is an indication on how scores in a distribution are scattered or dispersed. Okay, there is variability when you see how scores in a distribution are scattered or dispersed. And what are the different measures of variability? Yan, we have the range, average deviation, interquartile range, standard deviations, semi-interquartile range, and variance. Okay, let us differentiate this by watching some videos. Okay, first, we have to differentiate or we have to know what are quartiles and ranges.
Hello, welcome to Teach Me Maths. My name is Jonathan Hicks. We're doing quartiles and ranges. Yeah! Now this is a statistics topic. You really need to understand mean, median and mode before you watch this, particularly the median. You really need to know what the median is for this. Now mean, median and mode are all types of average. Quartiles are sort of related to averages, and range is just another way of measuring the sort of spread of the data. They're very straightforward though, so we'll dive right in with a list of numbers. This is very similar to the numbers I used for the mean, median and mode video. So imagine we've gone around a bunch of families and we asked each family, how many children do you have? And I wrote down all the answers, and these are the numbers I've got. So I've got a slightly different list from before. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers this time. Now the range, we'll do that first, that's the easiest one, is simply the highest value minus the lowest value. So the range for this set of numbers is going to be 5 minus 1, so it's 4. That's easy. Now, quartiles. Before we come on to the quartiles, you need to understand what the median is. And so just to remind us, we're going to work it out again for this set of numbers. So the median is the one in the middle, remember? Median, think medium, the one in the middle. And you just pair your way in from the outside. So if that goes with that goes with that, pair, 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 that's the one in the middle. So that is the median. Yeah, 3. Now if the median is the number that's halfway through the list of numbers, the quartiles, well, first of all, if we do the lower quartile is the one that's a quarter of the way through the list of numbers. So the lower quartile, quartile, often that's abbreviated LQ. So as I say, median is the one that's halfway through the numbers. The lower quartile is the one that's a quarter of the way through. Now, the easiest way to do that is you don't need to pair from the end or anything. Once you've found the median, just take the list of numbers that are on the left of the median, the first half, don't include the median. So start with those two and pair your way into the middle. So that pair, that's the one in the middle of the first half. So that is the lower quartile. It's 2. That's the one that's a quarter of the way through. Yeah, so that'd be a quarter of the way through, halfway through. You probably figured out by now, if the lower quartile is the one that's a quarter of the way through, the upper quartile, often abbreviated to UQ, is the one that's 3/4 of the way through. So again, like you did with the lower half, you pair your way in. You just take the upper half and you pair your way in. So don't include the median. Start from these ones. Pair, pair, that's the one in the middle. So the upper quartile in this case is 4. So those are the key quartiles. As I say, median is halfway through, lower quartile is a quarter of the way through, upper quartile is 3/4 of the way through. But you just pair in with the bottom half for the lower quartile, pair in with the top half for the upper quartile. Now if the range is the highest value minus the lowest value, the next thing we do is the interquartile range. Inter just means between, so it's the range between the quartiles. So it's simply the higher quartile minus the lower quartile. So that's very easy to work out. The interquartile range is simply the upper quartile value, so 4, minus the lower quartile value, so 2, and 4 minus 2 is 2. And that's it. So the interquartile range will be 2. So those are the quartiles. These can get a little more difficult when dealing with large lists of numbers, but the concepts don't change. Just like mean, median, mode, if you can get your head around the concepts here, you'll find it's a lot easier when dealing with a larger list of numbers. My name is Jonathan Hicks, and you're watching Teach Me Maths.
That is how we compute quartiles and ranges. Okay, let's move forward. Now, let us know what our standard deviation and variance are. See.
In this video, we're exploring standard deviation, the statistics term you may or may not remember, but will find handy when it comes to analyzing your assessment data. Before we dive in, let's start with a fundamental math concept we all understand: mean or average. You can find the mean easily by adding up all the scores and dividing by the number of scores there are. Think a little deeper about the mean, however, and you'll start to realize it masks a lot of what's really going on with your data. Standard deviation reveals just what the mean might be hiding. First, let's take a closer look at what standard deviation is, and then how you can use it to make sense of your data, starting with a simple definition. A standard deviation describes how spread out scores are. In other words, how far they deviate from the average. Mean scores are very helpful to get a sense of how a group is doing. But when score reports include mean scores without standard deviation, it's hard to see just how spread out the scores are. That's because mean is just one number to describe how the entire group of students performed. Let's consider two different classes, Class A and Class B. And for simplicity, let's pretend these classes only have 5 students each. In Class A, students have scale scores from 610 to 645. The mean score is 625. Now let's look at Class B. Students in Class B have scores as low as 550 to as high as 725. Very different scores from Class A. However, Class B has the same mean score as Class A. Even so, the spread of the scores are very different. The scores of Class A are all very close to the mean, but the scores of Class B are more spread out. The standard deviation is a way to quantify just how much the scores are spread out and tells you, on average, how far away the scores are from the mean. We'll spare you the calculation, but the standard deviation of Class A is about 14, and the standard deviation of Class B is about 78. Since Class B's scores are more spread out, Class B has a greater standard deviation. This means there is more variation in the Class B results, something the mean would not be able to show you. To see how standard deviation applies to assessment reports, let's imagine you have scores for an entire grade from a district. We can show these scores in a histogram, which counts up how many students had each score. Test scores often follow what is called a normal distribution, particularly when looking at large populations of students, which you may know is a bell-shaped curve. In a normal distribution, the mean is at the center. In this case, the mean of these scores is 625, and the distribution is symmetrical. About half the scores are above the mean, and half the scores are below the mean. The neat thing about a standard deviation is that when data are normally distributed, like they are here, about 2/3 of the data, or 68% of the data, are within one standard deviation from the mean, which means that just by knowing the standard deviation, you also know how most students scored on their assessment. In this case, the standard deviation is 20, so about 2/3 of the scores are 20 points above the mean or 20 points below the mean. That's between 605 and 645. If you were to multiply your standard deviation by 2, also known as calculating 2 standard deviations, you would capture approximately 95% of all data. About 5% of the data are beyond 2 standard deviations, or greater than 40 points above and below the mean. These scores that are beyond 2 standard deviations are in the tails of the distribution. These students earned very low or very high scores compared to their peers. When you see the mean and the standard deviation on a score report, it can help you get a quick idea of the distribution of students' scores by adding and subtracting 1 or 2 standard deviations from the mean. Take, for example, one school that has a mean of 600 and a standard deviation of 20 for a grade level, while another school in the district for the same grade also has a mean of 600, but a standard deviation of 100. On the surface, these schools might look like they're performing similarly because they have the same mean, but the spread of the scores is completely different. At the school with standard deviation 20, most student scores are in the range of 560 to 640, which is 2 standard deviations from the mean of 600. At the school with the standard deviation of 100, most students are in the range of 400 to 800. Those scores are much more spread out. Using standard deviation, you have a much clearer understanding of what's going on. and can make more informed decisions on where additional resources, scaffolding, or teacher-led intervention might be required. On the diagnostic reports for ExactPath, standard deviation is reported inside parentheses next to the average score. You can add and subtract this number from the mean to calculate the range of scores within one standard deviation. On the class results report, teachers can use standard deviation to see how spread out scores are within a single class. Our aggregated report also includes the standard deviation of scores from whole grade levels within specific schools and across the entire district. Now, when you see mean scores with numbers in parentheses after them, labeled SD, you'll know what's really going on. Averages can be deceiving, but the standard deviation will help you get a sense of what the distribution of scores really looks like. We hope you're as excited as we are to go check out your own score reports and apply your knowledge of standard deviation.
Okay, that's it. That's how standard deviation and variance are. Okay. Next, is another trivia. Si Carl Pearson na naman, in 1892 and 1893, introduced the statistical concepts of the range and standard deviation. Siya yung nagpauso niyan. Siya yung nag-introduce ng concept na yan sa atin. Si Papa Carl Pearson na naman. Okay? And next, we have skewness. Okay, skewness means it tends to have a long tail on one side or the other side. And there are two kinds of skewness. We have the negative skew and positive skew. In order for us to understand skewness, let's watch this.
We went to a school and noted the heights of a very large set of students. Let's make a line to denote their heights. The heights recorded were in meters. The heights recorded were between 0.9 and 2.1 meters. Let's mark heights with intervals of 0.2 meters, like 1.1, 1.3, 1.5, and so on. If we plot the number of students on this axis, then this is the data we get. Maximum at the 1.5 meters line. Equally distributed on both sides of 1.5, which is the central value. This point is the maximum. This type of distribution is called normal distribution, and the data is distributed equally on both sides of the central value. It is also referred to as the bell curve, as its shape resembles a bell. But is the data always normally distributed? Does it always look symmetrical along the central value line? We look at an example to understand this. We wanted to look at the graph of income distribution per annum in a particular region. Say we have the incomes on this line. Let the income be in thousands of dollars. The range going from $10,000 to $100,000. Let's zoom in to look at the data closely. This is what we found. Majority of the people earn somewhere between $20,000 and $50,000. Very few earn less than $10,000 and very few earn more than $100,000. Here, the central value is around $50,000. Look at the figure closely. We can see a long tail on the right-hand side of the central value. Yes, it surely looks like a tail. But there's something important we need to know here. As the tail is on the positive side of the central value, we say that the distribution is positively skewed. It is not equally distributed on both sides of the central value. This is skewness. If we compare it to the normal distribution curve, we can clearly see the difference. Then what is negative skewness? To understand negative skewness, let's take a very simple example. We have the data of the marks scored by students in an easy test. Let the marks range from 20 to 80. We zoom in to understand the data we gathered. This time, the distribution looked something like this. This is the distribution of marks of students. Majority of the students scored between 50 and 80, while the central value is 50. We see a tail here as well. But this time, it lies on the left-hand side of the central value. Because it is skewed towards the left-hand side of the central value, we can say that the data is negatively skewed. Now let's zoom out to see all three distributions. In the normal distributions case, the data is distributed equally on both sides of the central value. In cases where the data is skewed, the distribution is not equal on both sides. If the tail is towards the right side of the central value, we say that it's positively skewed, and if it's towards the left, it's negatively skewed.
Okay, that's it. Okay, let's see another example. This is an example of income distribution. As you can see, it is an example of a positive skew because the long tail is on the positive side of the peak, and some people say that this is skewed to the right. So the mean is on the right of the peak value. So ibig sabihin nito, mas konti yung mga taong kumikita ng money from $60,000 to $100,000. So as you can see, this is positively skewed. In fact, the tail continues way past $100,000. Okay. Next is the normal distribution. We say that the data is normally distributed when there is a symmetry about the center, which means the mean is equal to median and mode. The 50% of values less than the mean and 50% greater than the mean. Okay? We say that the data is normally distributed when it is perfectly symmetrical, and the mean here is exactly at the peak, and it's often called bell curve because it looks like a bell. So in normal distribution, most often, many things closely follow the normal distribution. Like for instance, the heights of people, okay, the size of things produced by machines, errors in measurements, blood pressure, and marks on the test. So let's move on to the next, the standard scores. By the way, the normal distribution will be explained on the last video of this report. So let's move on to the next, standard scores. There are types of standard score scale, and the first one is the Z-score. What is the Z-score? The Z-score tells us where a score lies in relation to the population mean. And it tells us how far the score is from the mean. And this is very useful because it allows us to compare two scores coming from two different distributions. And next, there are two types of Z-scores. We have the positive Z-score and the negative Z-score. Positive Z-score means that the score is above the mean, while a negative Z-score means that the score is below the mean. In order for us to understand what we're talking about, here's a video about Z-scores.
Why do we need Z-scores? To answer that question, let's use a clever example about a fictitious measure of attractiveness. This is an imaginary scale that can be used to rate how attractive someone is. We use this scale to rate 3 men on their level of attractiveness. Shifty scores 35, Mickey scores 65, and Antonio scores 90. What do these scores tell us? Well, not very much. We know that Antonio is more attractive than Mickey or Shifty, but we know really nothing about how these three guys compare to everyone else who took the test. They could all be really ugly or really great looking. We don't know. So what else would be helpful for us to interpret the scores? It would be nice to know the average score on the test. We need the mean. So we go back to the attractiveness test validation study, we read the directions, and we find that the average score on this test is 60. Now we know a little more. We know who is above and who is below the mean. This will allow us to compute their deviation scores. For each guy, take his score and then subtract the mean of 60. Shifty, with his score of 35, is 25 points below the mean. Mickey, who scored 65, is 5 points above the mean. And Antonio, who scored 90, is 30 points above the mean. Now what we want to know is whether those deviations are big or not. How can we interpret these scores? How large are these deviations? In order to know whether the deviations are large or not, we need a standard to compare each deviation score. We need a standard deviation. Just like the mean is the average of all of the scores in the sample, the standard deviation is the average amount of deviation of all of the scores in the sample. The standard deviation can tell us whether the individual deviation scores are large or not. So we go back to the attractiveness test validation paper, we read the directions again, and we find that the standard deviation for this test is 10. With this information, we can divide each deviation score by 10 to compute a z-score. To apply the z-score formula, we first subtract the mean from each raw score, then we divide each deviation score by 10. The result is a z-score. Let's try that now. For Shifty, his z-score is a negative 2.50. Mickey's z-score is a positive 0.50. And the z-score for Antonio is positive 3.00. We can now look at a normal curve to get a better picture of where each score falls relative to other scores. Using our normal distribution, we can see that Shifty is way down here. Mickey is near the middle, and Antonio is on the upper end of the bell curve. This gives us a pretty clear picture of where these guys fall relative to other men who took the test.
Hey classmates, sir, to explain z-scores better, let me give you another example. So, for example, if you want to know how well you are performing in your psychology class compared to your philosophy class, for instance, you cannot simply compare your grades from the two classes since each class is composed of a different population, right? So, if you got a grade of 90 in psychology and an 85 in philosophy, for example, it would not automatically mean that you were doing better in your psychology class. So, if most of the psychology students were getting scores in the 90s, then you might just be performing in the average. Then, if most of the philosophy students were getting scores in the low 80s, then pwede mong sabihin na you might even be one of the top performers in the class kahit 85 lang yung grade mo sa philosophy. So, the only way to find out would be to convert each of your scores in the two classes into z-scores. Yan yung gamit ng z-scores. Let's say you got a z-score of 1.0 in psychology and 1.2 in philosophy. This would tell you that even if you got a lower score in philosophy, you are actually performing better in that class compared to your psychology class. So that is how Z-score is interpreted. Okay, next is the T-score. What is a T-score? The T-score is based on a normal curve. And the T-score of 50, standard kasi ito eh. So the T-score of 50 is equal to the average score of some comparison or norm group. Then, approximately 2/3 of the scores in that norm group will fall between a T-score of 40 and a T-score of 60. And this is the average range. And the relationship of T-scores to percentiles is shown on the next slide. And para maintindihan natin. As you can see, sabi ko nga kanina, a T-score is a standardized score based on the normal curve. So, dito, bibigay ko example sa inyo based on this table. So, I want you to listen carefully so that you'll be able to understand. Halimbawa, suppose we paano ba example na bibigay ko sa inyo dito? Halimbawa, si John, okay, ni-refer natin siya for an evaluation to see how he might fare in a prison setting. Okay? And suppose that after we tested John, we found out that John's community T-score is equals to 73. So, we will say that relative to people in our neighborhood, for example, he has a very high score kasi nandito siya greater than 70, so 73. This would translate that he is included in the 97% greater than 97% percentile rank. And this would indicate that he is more antisocial than 99% of persons in our community. Pero, this might not be very meaningful because pwede nating isipin na most persons in the penitentiary would have a higher antisocial score than the people in our neighborhood. And another example, suppose when we compare John's score to an average prisoner naman to find if he has a prisoner T-score of 60. Tingnan natin kung medyo bababa. So for example, we could say that when we compare him to the other prisoners, our subject is at the 84% percentile rank. Kasi kung halimbawa yung T-score ni John is 60, so he belongs to the 84% of the reference group. Then this suggests that John is not only more antisocial than the average person in our community, but he also appears to be more antisocial than an average prisoner. Nasa score level pa siya ng high Kasi greater than 60 ang kanyang T-score and his percentile rank is greater than 84%. So, this would mean that we have to be extra precautious when we deal with John, kasi mataas pa rin yung kanyang anti-social score level. So, dyan ginagamit yung T-score. Okay, next, there are other standard scores. We have this T9 score, and this is derived from a national norm reference sample. And for example, if a score from 1 to 9 with a T9 of 9, it indicates that a very high level of general ability relative to the whole norm reference group. But if the standing score is 1, it means that the person has a very low relative achievement. For us to understand this, I will show you another video. Okay, that's it. Okay, next is a row score. A row score is simply the number of correct answers a student gets on a particular test. And standard scores converted from row scores may involve either linear or nonlinear transformations. Linear transformation means it is to transform data from one measurement scale to another. So this means we convert data from another measurement scale. And the nonlinear transformation means it points that in a plot of the transformed variable against the original variable, would not fall on a straight line. Ano bang ibig sabihin yan? Okay. In order for us to understand the difference between the linear and non-linear transformation, I would like to show another video.
Often it is necessary to transform data from one measurement scale to another. For example, you might want to convert height measured in feet to height measured in inches. Linear transformations involve multiplying a variable by a constant and then adding a second constant. This table shows the heights of 5 people measured in both feet and inches. To transform feet to inches, you multiply the number of feet by 12. For example, 5 feet times 12 inches per foot equals 60 inches. Some conversions require that you multiply by a number and then add a second number. For instance, the transformation between degrees centigrade and degrees Fahrenheit requires that you multiply by a number and then add a second number. For the conversion from centigrade to Fahrenheit, the first constant, or the number you multiply by, is 1.8, and the second constant, or the number you add, is 32. So, to convert from centigrade to Fahrenheit, you multiply degrees centigrade by 1.8, and then you add 32. This table shows the temperatures of 5 U.S. cities in the early afternoon of November 16, 2002. The temperatures are given in both Fahrenheit and Celsius. To convert Houston's temperature in Celsius to Fahrenheit, multiply Houston's temperature in Celsius, 12.22, by 1.8, and then add 32. This equals 54. Here you see a plot of degrees centigrade as a function of degrees Fahrenheit. Notice that the points form a straight line. This will always be the case if the transformation from one scale to another consists of multiplying by one constant and then adding a second constant, keeping in mind that the second constant may be 0. These types of transformations are therefore called linear transformations. If a new variable y is created from variable x using the formula y equals bx plus a, where b and a are constants, then y is a linear transformation of x. In the temperature example, y is degrees Fahrenheit, x is degrees centigrade, b equals 1.8, and a equals 32. Many transformations are not linear. With nonlinear transformation, the points in a plot of the transformed variable against the original variable would not fall on a straight line. Examples of nonlinear transformations are square root, raising to a power, logarithm, and any of the trigonometric functions.
Okay. Those are linear and nonlinear transformations. Okay, next, we have the normalized standard score, and it is defined as a procedure in which each set of original scores is converted to some standard scale under the assumption that the distribution of scores approximates that of a normal. Okay, in order to understand standard scores, let's watch this video.
Some tests are designed to be administered with procedures so that there is consistency from test taker to test taker. This enables comparing test taker scores like apples to apples. Such tests are standardized, and they provide standard scores, which compare a test taker's performance to same-age peers. Knowing how standardized tests are created helps with understanding what standard scores really mean. First, the test developer designs a task, which could be solving math problems. The developer then gives the test to a group of people, called a norming sample, that represents the population, along the lines of things like gender, ethnicity, and location. Let's say the developer gives the math test to 100 16-year-olds in the norming sample. The scores of all of those 16-year-olds are folded together into an average or mean, which may be 26.7 correct answers out of 40 problems. On this math test, most of the 16-year-olds earn scores that are pretty close to the mean of 26.7 correct answers. Relatively fewer earn scores that are higher than the mean, and even fewer earn scores that are a lot higher. Similarly, few earn scores that are lower than the mean, with just a handful earning scores that are a lot lower. By the way, this is a bell curve, named for the shape that a group typically makes with a lot of members in the middle, near the mean, with fewer members at either extreme. Standard scores indicate how a test taker performed relative to the members of the norming sample, or where that person would be in the bell curve. Standard scores are computed by taking the points the test taker earns, called a raw score, and comparing them to the performances of same-age peers from the norming sample. For example, Jessie takes the math test and gets a raw score of 33. Now, 33 out of 40 may not seem too impressive, but considering that the mean of the norming sample was 26.7 and that she performed better than the majority of other 16-year-olds, Jessie actually did pretty well. So she would earn a strong standard score. In essence, standard scores are comparison scores that indicate how someone did relative to same-age peers. Again, apples to apples. Standard scores do not represent amount of ability, knowledge, or skill. Rather, they compare a person's ability, knowledge, or skill to that of other similar people. There are several types of standard scores, but they all are organized under the bell curve. Most standard scores have a mean of 100, such as intelligence or IQ scores. Subtest or scaled scores range from 1 to 19, with 10 being the mean. For T-scores, 50 represents average performance. With percentile scores or ranks, 50 is average. If a student earned a percentile score of 56, then his performance was as strong or better than 56 out of 100 other students his age who also took the test. Standard scores 85 or below are uncommonly weak. Same for subtest scaled scores of 7 or below, T-scores of 40 or below, and percentile scores of 16 or below. Standard scores 115 or higher are uncommonly strong. Same for subtest scale scores of 13 or higher, T-scores of 60 or higher, and percentile scores of 84 or higher. The average range is considered to be the middle of the bell curve, from 1 standard deviation below to 1 standard deviation above the mean. It may seem really broad, but percentile scores between 16 and 84 are in the average range. It all relates to the bell curve. Most people will score near the mean on a test, placing them in the big area under the curve, with relatively fewer towards the right with higher scores, or towards the left with lower scores. Whatever the metric, a lower standard score means most same-age peers performed better on that test. At 2 standard deviations below the mean, a standard score of 70 is the same as a subtest or scaled score of 4 and a T-score of 30, all of which are at the second percentile. So a 16-year-old who gets one of these scores performed better than only 2 out of 100 other 16-year-olds. Standard scores close to the mean represent performance that's typical for someone that age. A 16-year-old with one of these scores performed better than half of other 16-year-olds. A higher standard score means most same-age peers did not perform as well on that test. At 2 standard deviations above the mean, a standard score of 130 is the same as a subtest or scaled score of 16 and a T-score of 70, all of which are at the 98th percentile. A 16-year-old with one of these scores performed better than 98 out of 100 other 16-year-olds. Again, think of standard scores as comparison scores, apples to apples, or in this case, 16-year-olds to 16-year-olds.
Okay, that is how we explain standard scores. Okay, thank you very much for listening. I hope that somehow I was able to give you insights about the different statistical terms that we will come across as we study psychology and as we do our research, or as we um, um, uh, study this subject, psychometrics. I have prepared a 44-page handout for you. All the details that you need to know about the terms that we discussed are here. I have placed different diagrams, and also all the suggested videos that you should watch in order to understand them better are also placed in the handout. Um, I will send. I already sent. I will send you the handout via email or via the messenger, and I will also send you this video so that you can watch it over and over. And here, okay, these are my references. I also placed them in your handout. There. Medyo mahaba siya. Madami talaga akong pinuntahan so that I can make this report easier to understand. And thank you for listening. Have a happy weekend. And before we end this, I would like to share with you that this book by Bluman, Elementary Statistics, a step-by-step approach, I really recommend this book when you want to study statistics by heart, because the author was able to encapsulate all the terms in statistics in easier manner. And I also would like to recommend a website. It's pdfdrive.com. In that website, you can download different books across different subject areas. Maraming books doon about psychometrics, about science. Lahat talaga nandun because more than 70 million books are placed in that website, and you can download them for free in PDF form. And I hope that you have understood all the things that I've said today. I'm not an expert. And as I've said earlier, that when I hear the word statistics, talagang kinakabahan talaga ako. That's why this report is really a challenge for me. Nag-aral talaga ulit ako in order to deliver this report to you. Thank you very much. Okay. See you next Saturday. Okay. Happy weekend and God bless. Bye. Then stop recording.